अपने स्टूडेंट्स एंड तलबा से कहूँगा कि वो इस मुल्क का एक बहुत बड़ा असेट है और उन्हीं को आगे चल के इस मुल्क की बागडोर संभालना है।
Hello, Excellence.
What is excellence?
Excellence isn't something that happens overnight, but it's a gradual process.
Excellence is not a destination, it is a journey, and we pursue excellence every day in our lives.
Here at Integral University, we understand that every person is excellent in their own unique way, and hence we devise programs to bring out their excellence.
Imagine an engineer who can build a wall with his or her own hands. Imagine a person who just graduated and knows how to fix a bicycle or a motorcycle for that matter. Such is the skilling that our university believes in imparting to our students.
Excellence does not only means advancement in education but also becoming socially and emotionally mature enough to face the life and facing oneself.
Hello, Excellence.
The hands-on training imparted through our agile curriculum and imparted by our faculty with considerable industrial experience in the manufacturing, corporate, agriculture, law, medical and architecture fields, for example, allow our students to start delivering value to their employees and employers immediately.
At Integral University, pursuit of excellence is full of happiness, knowledge, friends, teachers, and yes, last but not the least, dreams.
Excellence is when you gather new knowledge every day.
Excellence is when you stay focused.
Excellence for me is setting a goal and achieve it.
That is the excellence we are targeting.
Hello, Excellence.
Hello, Excellence. Hello, Excellence.
Hello, Excellence.
Hello, excellence.
Learn,
Grow,
Smile.
and keep going.
Welcome to the world of excellence.
Integral University, Lucknow. Inspiring excellence.
A very good morning to the dignitaries, guest speakers, faculty members and dear participants. I, Dr. Asma Farooq, working as Associate Professor in the Department of Commerce and Business Management, extend you all a very warm welcome on the third day of Quality Improvement Program, which is based on research methodology and data analysis. The topic for today's session is framing of objectives and hypotheses. I personally believe that after the selection of the topic for your research work, framing of objectives and formulation of hypotheses is the foundation stone of a good research work. Mental dexterity and technical know-how of the chosen field is required for hypothesis and objectives formulation. And I hope you would be learning a lot from today's session, which is a very crucial part of any research methodology. As we move forward, I take the privilege to invite our Dean, Professor A.K. Saxena, sir, to accord his opening remark on the today's session.
Thank you very much, Dr. Usma.
Yes,
Thank
sir.
you very much, Dr. Usma. My first duty is to welcome the guest, Professor Bilal Mustafa Khan Sahab, who is the key speaker of the day. His photo is not coming. His photo is not visible. Anyways, Professor Bilal Mustafa Khan is a young entrepreneur serving the Faculty of Management Studies, AMU, one of the premier departments of the country after the Motilal Nehru Institute of Research and Business Administration, Monirba University of Allahabad, which is older than IIM Ahmedabad. The first batch passed out in 1965-66 at Allahabad. Thereafter, the programs started the name and AMU, BHU and Allahabad. So these are the field of excellence. Religious duty is to welcome you, Professor Bilal Mustafa Khan Sahab. I personally welcome you on behalf of our Chancellor, Dr. Syed Wasim Akhtar Sahab, Co-Chancellor, Dr. Syed Nadeem Akhtar Sahab, our Vice Chancellor again from AMU, Professor Javed Masarrat Sahab, our Pro-Vice Chancellor, Professor Akil Ahmed, and our Dean Doctoral Science, Professor Usmani Sahab, and Dean Research and Development, Professor Haq Sahab. On behalf of the Faculty of Commerce and Management, as well as on my personal behalf, I welcome you, Professor Bilal Sahab, to have accepted our invitation to speak on such an important topic, that is testing of hypothesis, the framing of hypothesis and objectives and its framing. To my mind, with the little experience I have got, hypothesis testing is in the heart of any PhD thesis, and it is now without any disagreement we have reached to the point whether the research is based on the primary data or secondary data, one should go for framing of the hypothesis testing. It is not always true that in the case of the research which is based on the empirical study, the primary data, you should frame the hypothesis statement. If you formulate the hypothesis statement, it will give you good results. With these remarks, once again I welcome you to deliver your talk on the today's third day of this 2 weeks workshop, and now it is over to Dr. Asma Farooq to kindly proceed. Thank you very much.
Thank you, sir, for your eloquent and well-articulated opening remark. And enthusiasm while giving his opening remark, and it adds ardor and favor in me and the participants online. So without wasting much of time, again I would be requesting the head of the Department of Commerce and Business Management, Dr. Syed Shahid Mazhar sir, to introduce our dignitary speaker from Aligarh Muslim University. Over to Shahid sir.
Thank you, ma'am. Respected Professor A.K. Saxena sir, Dean, Faculty of Commerce and Management. Esteemed speaker of today's session, Professor Bilal Mustafa Khan Sahab, learned faculty members, research scholars, ladies and gentlemen, good morning all of you. Faculty of Commerce and Management extends a warm welcome to all the participants. Now, let me have the joy of introducing the speaker of today's session, Professor Bilal Mustafa Khan Sahab. Dr. Khan is a professor in the Department of Business Administration, Aligarh Muslim University, and was a rank holder in the MBA program. An illustrious alumnus of AMU, he received his PhD in Business Administration from AMU Aligarh. Sir, we are really honored to have you here with us. He has more than 20 years of experience in teaching and research, and was also the head of the Department of Management Studies at Manipal University, Dubai campus, UAE. Dr. Khan was appointed as visiting professor at Asian Institute of Technology, Bangkok, Thailand, and to many other national and international universities as well. He has been regularly invited by leading business schools, universities, and academic bodies as a resource person for conducting faculty development programs and management development programs. In fact, I was fortunate enough to have attended one of his faculty development program, which he undertook in Triple IT Allahabad, if you recall, way back in 2008 or 9 something. And he is one of the pioneers in using statistical softwares like SPSS, AMOS, and Lizril for academic research. Dr. Khan is a renowned SEM expert, which is structural equation modeling, and has been invited to conduct many workshops on research methods, on exploratory factor analysis, CFA, SEM across India and abroad. He has published nearly 100 research papers in both national and international journals of repute. Dr. Khan's research papers are widely cited, and he has collaborated with many foreign authors in the area of cross-cultural research. He has traveled to Europe, Africa, and Middle East for academic and other activities. His research interests are luxury brands, advertising, social media, and structural equation modeling. Dr. Khan is an active academic administrator and has served as a member in various committees of Government of India. He has a unique blend of researcher, academician, writer, avid reader, and an active sportsperson. What a combination. Obviously, we are endowed to have such an experienced person to guide us for today's session. Sir, thank you so much for accepting to be with us. And I'm sure this session is going to be phenomenal for all of us today. May I invite Dr. Khan to address the participants.
Thank you very much, Professor Mazhar sir. You have already, you're too kind, too generous with your words. You have, unnecessarily built up an expectation. The audience is going to have an expectation, and that's going to weigh on me in this particular presentation. And nevertheless, I'll try to do justice to this. As you can see, as you had said, my area is basically marketing, brands, advertising. That's my area. But nevertheless, this area, like any other area, you have a lot of interface with research methodology. And actually, when you are guiding scholars, when you are writing papers, so I personally feel that irrespective of the fact whether you are from you have a statistics background, or whether you are a hardcore marketing person or a finance person, you need to be good in research methods. That's my personal take. My area, as you said, is actually areas that I'm very, very conversant with. The areas that I like to work on is actually SEM. But nevertheless, a part of any good research starts with the very basic question, the research questions, the objectives. So we'll try to take up those things today and in the coming few minutes. And with this, thank you very much. I'd like to open up the PowerPoint presentation and take it from there. So thank you Mazhar sir, thank you Asma ma'am. So I'll just open up the PowerPoint presentation, and I'll just share my screen. I hope I am visible to everybody today. And this is going to be the agenda for today's discussion. As you all know, the topic for discussion is basically how do we frame the objectives, and what is the relation with objectives and hypothesis. And obviously, this has to do with the overall research methodology, that is objectives, hypothesis, framing of hypothesis, variables that are involved, the kind of statistical tool that you will apply. All those things are all, the part of, the bigger thing called as the research methodology. So without taking much time, I'll just go ahead and let me just, put up the agenda that's there for today. So first we'll have a look at what objectives are and, how do they relate to hypothesis. And then we'll talk of the different types of hypothesis. What exactly is a hypothesis? What is null and alternate hypothesis? These are the terms that we have been hearing. There are a lot of misconceptions regarding these two words. We'll try to address those to the best of my ability. And then we'll talk a little bit about, the hypothesis testing part. Okay. So that's how it's going to be. So if you look at this, this is the slide tells you this is how the research is all about. When you are actually developing a conceptual framework. Okay. Now, first thing is obviously in any research, the premise of any research is.
Excuse me, sir. Sir.
Yes. Yes.
Your video is not available. The slide is visible, but you are not visible.
Okay. Just a second. Hold on, please. Okay. Is it okay now?
Yes.
Am I visible? Okay. So you can see we are actually, any good research starts with a question. The basic premise of any research is a question. Now, I had a opportunity to address some people in a workshop a few months back, where the topic of the workshop itself was the relationship between research questions, title, objectives, hypothesis, conceptual framework, theoretical framework. Now, many of these things are, they look very mundane, but there are intricate and I should say small differences which we need to address. So first, what I'll do is I'll just start with the research question. So any research, like I said, starts with a basic question. Okay, and ultimately, you could collect data, and the research could take different forms. It could take a qualitative form, it could take a quantitative form, but you actually start with a question, and you may have a dilemma, and because of that particular dilemma, you may, it may spur you on. Okay, so if you look at this, how do we distinguish between what exactly is a research objective and a research question? Okay, research objective is basically, you want to indicate the outcomes of a particular research. Like, for example, you may have things like this: to identify the determinants of customer satisfaction, to identify the factors affecting XYZ, to develop a model, to develop a framework. These are basically your objectives. So ultimately, the expected outcomes are termed as your objectives. But most of the research is actually driven by research questions, and there is a direct relationship between the research question and the formulation of the hypothesis. Okay, now there's one thing. So there's a question: what do we do in any research? Do we include the research questions and the research objectives, or they're mutually exclusive? So I'll tell you, the correct way to do is, this is what I have actually, with my experience and with what I have seen, in other researches. What I find is that any research, obviously you have a title. Many people, rework the title later on. But the question, the first thing that, you need to do is, in any good research, is that you need to have the research questions. And I'll tell you why research questions are vital. And they're followed by the research objectives. Okay? And the research questions actually formulate your hypothesis. They actually guide you, help you in formulation of the hypothesis. So research questions and research objectives, the trend is to include both of them. Many people in many researches, you'll find that only the objectives are listed, not the questions. In many researches, you will find that only the questions are listed, not the objectives. But the right way to do is, first you need to have the questions, which are followed up by the objectives. Okay, because ultimately it is the research question which is going to guide your hypothesis formulation. Okay, now another important aspect, it's about the kind of study that you are undertaking, that is a quantitative study or whether it is a qualitative study. In qualitative study, you usually do not have the hypothesis. So research questions actually double up for the hypothesis. So you can think of the hypothesis in terms of research questions, actually when you are talking of, a qualitative research. But when you are talking of a quantitative research, you have hypothesis, formulated hypothesis, and hypothesis, as you might have heard of, null, alternate hypothesis, and those hypotheses are to be tested empirically. So in a quantitative study, the structure is you have the research questions, the objectives, and then you have the well-formulated, I should say, research hypothesis, which are to be tested empirically. Okay. So generally, the universal trend is you don't actually have what you call as, the research hypothesis when we are talking of the qualitative studies. So research questions double up for qualitative studies. That's the trend. Okay, I'm not saying what is correct and what is not correct. Okay, I'm just telling you what the trend is. So a lot of researchers choose to just only have the objectives, while some only choose to have the research questions. But ideally speaking, examining the trend, examining the literature says that actually people have researched this also. So the literature says that, you know, a good research, or for the new researchers, we need to have the research questions as well as the research objectives. And there is a direct link between the research questions and the hypothesis formulation. Okay, but in a qualitative study, you do not actually have hypothesis. So you can think of research questions as the hypothesis. Okay, but they are not formulated the way they are formulated in a quantitative research. Always remember that in quantitative research, the research hypotheses are formulated hypotheses. Okay, we use the word formulated hypothesis. So I'll come to that when we come to, you know, the formulation of hypothesis. I'll take that up. Okay, so this is very briefly about these two things. Now I'll just give you an example. This was a study, and actually this was a study conducted by myself. You know, when I was you know, a scholar, and that was way back in 1998. And my study at that point of time, because I had worked in an organization, and my organization, you know, actually was into total quality management as a philosophy, as a concept. So I was highly enamored when I was working in that particular organization. And the interesting thing that if time permits, I'll give you a brief, you know, background of, you know, what I did and why this topic became important, and, you know, the issues that I faced with this. So very briefly, I was working in a company which was dealing with total quality management implementation, you know, and when I took up what I should say research, I chose this particular topic. Today, I have made a complete break, you know, from what I had done as a, you know, PhD scholar and what I'm doing right now. So my study was actually qualitative in nature. It was in areas of, I should say, general and strategic management. Today, I am in the areas of advertising, branding, luxury brand. So basically advertising and branding. So that's a different story. So this was basically the topic. And, you know, I had framed research questions like these, you know, what is total quality management and its role in delivering superior service quality? Now, these were some of the questions, you know, that you will always have. So any researcher will have certain questions in mind. Okay. Now, what exactly is a hypothesis? I'll tell you. Hypothesis is mostly more in a statement form, you know. So there is a relationship between TQM and superior service quality. Let me say this way. So I just framed a hypothesis by looking at the question. So ultimately, you know, your research questions guide you, you know, in terms of your hypothesis development. Okay. Now, research objectives are basically the outcome. So if you look at my first research objective, it says to identify the management system. So ultimately, the outcome of the study, to develop a service quality system or model. So objectives are your expected outcomes, what you want to achieve. They are very closely linked to research questions. So research questions, research objective, and hypothesis, they're all very closely linked together. Okay. So this is merely an example. As we go along, we'll discuss a few more things, and I'll share certain, you know, hypotheses which have been formulated, certain research models, and how those hypotheses have been formulated. Okay. So the sequence is, you have the, you know, your research questions, research objectives, and ultimately you'll have your conceptual model, you'll have your hypothesized model, which will include the hypothesis. So that's the relationship. Okay. So how do we connect the dots? The dots are, you have the research question, you have the hypothesis. Okay. So research question actually help you in formulating the hypothesis. And ultimately, the hypothesis revolve around certain variables in question. Like, for example, I have a hypothesis. My hypothesis could be, and it's a question, you know, I've always wondered, you know, if you know, female students are better than male students. You know, when I was an MBA student, I firmly believed in this, that, you know, female students generally tend to outscore male students. So that could be, you know, my theory. And I want to test this. So I formulate a hypothesis that, you know, that females, you know, are you know, they score more, or they're better than, you know, males. So this is one of the things that, you know, I would want to test, empirically test. So what I'll do is I'll collect a data, but then the data would be collected on the basis of the variables, which are involved. So here the variable is basically your exam score and the gender. So male and females and their exam score. So ultimately, this is how you connect the dots. You have the research questions, you have the research objectives, and then you have the formulation of the hypothesis, and then you have the variables. Okay, we'll come back to this in a few minutes. Okay, now, so research question actually, is presented in the form of what, how, why, when, and ultimately this will depend on the kind of study that you are conducting. Okay, so if you are conducting, let's say qualitative study, you would probably be studying a phenomena at work. Okay, so when you are studying a phenomena at work, by the way, this is not part of the topic, but very briefly, let me tell you, qualitative studies are the most difficult type of studies to conduct. Quantitative studies are much more easier because you do have a formula, you do have some statistical test. So when you are studying a phenomena at work, you want to see, how things happen, what, and there's a very good book, by Yin, if you want to actually go into qualitative research. Okay, now in quantitative research, you are only interested in, generally describing the data, finding the differences between groups, finding the impact of one variable on another. So your question would be presented accordingly. Okay, so next, let's come to what exactly is a hypothesis. Hypothesis is basically, when a researcher begins writing a hypothesis, actually when he picks up a research topic, he generally has an idea in his mind. Like, for example, I just gave you the idea that I personally feel that female students are better than males. Okay, so my question was, are female students better than males? Okay, and in terms of their exam score. So this could have been my research question, and this thing which has been actually been in my mind for a long period of time, that yes, female students, I personally feel that yes, female students are better than males. So this is what I hope to actually predict with the help of so my hypothesis will be something which will be kind of predicting what I already think is correct. Okay, so the next thing in hypothesis actually related to quantitative studies is that you need to it should be something which can be empirically tested. So that is why you have those alternate and the null hypothesis. Okay, and obviously it can be empirically tested, and it can be tested to either you can accept the alternate hypothesis, or you can you fail to reject the null hypothesis. Things like that we'll take up in the next few minutes. Okay, so the point is that hypotheses are actually things that you want to predict, and you already feel that yes, things are going to be like this. Like, for example, if you go back in time, there was a gentleman called as Copernicus. Okay, you might have heard of him. In his time, there was an assumption, and that assumption was something which was held to be true. The assumption was that Earth is the center of the universe, and it is the sun which revolves around the Earth. Now, this gentleman, Copernicus, he had an alternate hypothesis. So that was the null hypothesis. Copernicus had an alternate hypothesis, and his hypothesis was that it is the sun which is the center of the universe and not the Earth, and it is the Earth which revolves around the sun. And that is what he hoped to predict with his hypothesis. Okay, so that's how it is. So in my case, what I would want to predict, the example of that, the girls are better, as compared to, boys when it comes to exam scores. What will I do? I'll write a hypothesis, I'll collect the data, okay, and I'll test it, and I'll see whether my hypothesis gets accepted or my hypothesis is rejected for lack of evidence. Okay, so hypothesis is generally thought of as something which you can predict. Okay, now, like I was saying, hypothesis is a researcher's prediction about the possible outcomes of a study. Look at this, there's a research question, and the research question is, does demographic heterogeneity in work groups decrease job satisfaction and organizational commitment of employees. So I have this, and this could be a good question. People could have this in their mind. For example, somebody who's working in the areas of human resources, he could have this in mind, that does demographic heterogeneity, so you could have people who are homogeneous in demographic terms, people who could be heterogeneous or homogeneous, and in terms of values, does it increase what you call as organizational commitment, or does it decrease job satisfaction? Does it increase job satisfaction? You could have a question like this, and the hypothesis that you could frame could be racial, ethnic, sex, and age diversity will increase turnover and tension of employees. But this hypothesis has been represented in the form of what you call as a alternate hypothesis, and this is actually a testable hypothesis. You could have another hypothesis which could be written in the form of racial, ethnic, sex, and age diversity will decrease job satisfaction of the employees. This is again, a testable hypothesis. More on this, in few minutes. These are some examples, of how you make the models. So in this particular study, we have our hypotheses are formulated in these ways that this is what we wish to prove, by the study, that marketing elements have an impact on dimensions of brand equity, and dimensions of brand equity have an impact on overall brand equity, and they're written in these ways. So these ways we'll discuss in some time when we do the initial discussion about what exactly hypotheses are, and we'll come back to this. I'm just showing you something so that you have an idea. Okay, so for all those of you who are actually into PhD, and so I'm just showing you that. Look at this now. For example, this is what I feel. This is my conceptual model, and I have the hypothesis here. So this could be my hypothesized model. I could call it that. So I have something here which says that entrepreneurial orientation has an impact on marketing orientation, which in turn has an impact on business performance. So there are mediators here and there are moderators here, like the environment. But all these are actually my hypothesis. Okay, so my conceptual model, when I put in the hypothesis, it becomes the hypothesized model, or the analytical model, the model that I'm going to test. Okay, and hypotheses are written, in this case, the hypotheses are written, these are in an alternate hypothesis format. So H1, H2, H3 are basically your alternate hypothesis. These are not the null hypothesis. So these are some of the models. We're not going to be discussing these models right now. We'll come back to them in a short while, just to give you an idea of what a hypothesized model is. Okay. Now let's come to this. What exactly? I've just told you what hypotheses are. Okay. Now how do we actually write and frame these hypotheses? That's the question. Okay. And as I said, hypothesis is actually an assumption or something that you are trying to predict. Okay, so my assumption was that female students are better than male students. So that is what I'm trying to predict. I'll collect the data on that. And as you all know, the world is dynamic, and therefore there are times when assumptions may not hold true. I gave you the example of Copernicus. So there was a time when, and it was given when people thought that Earth is the center of the universe, but Copernicus challenged that. Okay, so there are certain assumptions which may hold true at one point of time, and they may not hold true at a later point of time. So people will keep on challenging those assumptions. Okay, so what do? When we test the assumptions, there are only two possibilities: that the assumption continues to hold good, that is, whatever we believe, whatever the assumption is, it continues to hold good, or we believe that there could be evidence that this assumption is not going to hold good anymore. Okay, so always remember, a null hypothesis is something which is assumed to be true. Okay, I'll give you an example to illustrate this point, in a little bit more. And an alternate hypothesis is something which is a claim against the assumption. Now, we'll take up an example to illustrate this point. Okay, think of a jury trial. You know what is a jury trial? Or forget about a jury trial. Think of a court case. There's an accused. Okay, there's a person. Let's say there's a person who's accused of murder. Okay, and he is taken to the court. Now, what is the presumption? What is the presumption here? The presumption here is that the person is innocent or the person is not guilty unless proven otherwise. So as long as he is an accused, okay, he's merely an accused of a crime. He's not guilty of that. So he's assumed to be innocent. Understand this. He's assumed to be innocent. He's assumed to be not guilty. So what is the assumption? The assumption is that the person is innocent until proven guilty. Okay. So in this case, what is the null hypothesis? That the person is innocent or not guilty. And what is the alternate hypothesis? That the person is guilty or the person is not innocent, right? So that is your alternate hypothesis. So what does the prosecution do? Prosecution is, usually the state, okay? So, and obviously you can have other people assisting him. So what does the prosecution do? The prosecution tries to collect evidence. In a researcher's case, you try to collect data. So that evidence is also data. And based on that data will be presented to the judge. And the judge will examine that, data on a certain touchstone. And based on that, he will pronounce whether the person is, guilty or the person is not guilty. Okay, whatever it might be. Okay. Similarly, in your case, you will collect data and you will put that data in a particular through a statistical test, and then you will get certain values. You will analyze those values, and on those values will tell you whether your claim is to be accepted or it's to be rejected. Okay, so this is how it is. Now look at this. Let's continue with this judgment thing, because this judgment example is a very simple example. People from all disciplines can relate to this. So what are the possibilities in a judgment? Okay, there are only two possibilities. The person could be guilty or he could not be guilty. But let's just try to compare this with what we call as something, a real world thing, So with the reality, there could be four situations, One situation is that the reality could be that the person was guilty and he has been pronounced guilty. Just think of it this way, that the person had actually committed the crime. He had actually murdered somebody, and the judge, based on the evidence, pronounces him guilty. So you will say that the decision was right. There is another scenario that the person was pronounced not guilty, and in reality, he was also not guilty. So these are the two possibilities. There's another possibility, and there are the two other possibilities are that the person was actually not guilty, but he has been pronounced as guilty. And the other scenario is that the person was guilty and he has been pronounced as, not guilty. So there are four possible scenarios if you compare it with reality. Two things that we all know. That is, he was guilty and he has been pronounced as guilty. He was not guilty and he has been pronounced as not guilty. But there could be two other alternate scenarios. Those two alternate scenarios are pretty simple to understand. Okay, and what are those? That the person was actually not guilty, but he has been pronounced as guilty. That is, he didn't commit the crime, but yet he has been pronounced as guilty. We see this happening every day. There are instances where people were not guilty, but just because the evidence was presented in such a way, they have been found guilty. And in many cases, we have seen that the persons were guilty, but they were let go scot-free because the evidence was presented in such a way that it made it easy for them to not be convicted. So basically, what do we say? That this has very strong implications, okay, for understanding the concepts. Concepts like what exactly is type 1 error, what is type 2 error. Okay, look at this. So what has happened here is that the person was guilty, but we pronounced him not guilty. Such type of error is called as type 1 error, and it is represented by alpha. And there is another error which is called as the type 2 error, which is represented by beta. Okay, so what has happened here is the exact opposite of what has happened at the top. So the person was guilty, but what has happened? The judgment is that he is not guilty. Okay. So in the first case, what has happened was the person was, okay. So the person, see, just try to understand this. This is something very important for you to understand, type 1 errors and type 2 errors. So what happens in type 1 error? The person was actually, the decision is wrong. Okay. So he was not guilty, but he has been convicted. And in the second case, he was actually guilty, but he has not been convicted. So that's your type 2 error. So typically, we tend to keep alpha as 0.05 and beta as 0.01. Okay. Now, these are all standards. So alpha is a standard, 0.05, it could be 0.99 also. Okay. Now, can you tell me, any one of you, why do we have this distinction? Why do we keep alpha as 0.05 and beta as 0.01? Generally, there is this has a very important implication, not only in terms of your hypothesis testing related to management or criminal law. It could be universally applied. For example, in marketing, in new product development, we have something called as go error and drop error. The same thing, type 1 error and type 2 error. Go error and drop error. Go error means we allow a bad idea to, enter, or a bad product to go ahead and get further developed. And a drop error is we allow a good idea to be dropped. Okay. So same concept applies here. The reason why alpha is typically chosen as 0.05 and beta as this is because of the reason that jurisprudence states that even if 100 culprits are allowed to let go free, no innocent should be punished. So the standards are much more strict. So alpha is stricter and beta is not as strict for the simple reason that, we don't want to commit type 1 error. Okay. So we may commit a type 2 error, but we don't really want to commit a type 1 error. Okay. So this is what type 1 error and type 2 errors are. Okay. Now, there's some more terms which are involved. Okay. These are basically what you call as, the alpha, beta, and 1 minus beta is known as the power of the test. 1 minus alpha is known as the confidence level. Okay. So we all know about this 95% confidence, and 0.05% is your alpha, 0.05. We all know these terms. But when it comes to beta, there is some confusion, in minds of the people. And that is that, what is this beta? These betas are basically, we don't know the beta for the population, but these betas are actually your regression weights. So 1 minus beta is known as the power of the test. Okay. And this has implications for calculating the right sample size. So many times you might have come across the term, the power of the test. Now, p-value. People have a lot of confusion about what exactly this p-value is. P-value is nothing but the calculated probability. The probability, you calculate the probability of making a type 1 error. So p-value is nothing but the calculated probability of making a type 1 error. So let me just go ahead. How do we do this? We calculate the p-value, right? When we are testing a hypothesis, we calculate the p-value. And what do? We compare it with the alpha that we have set for ourselves. And I told you, alpha is basically a standard. Okay, so 0.05, when we say alpha is 5%, it means 0.05. Okay, when we say alpha is, 1%, we mean it is 0.01. So we have a standard in mind, and based on that particular standard, we compare it with the calculated p-value. Okay, so the software calculates the p-value for us, and then we compare it with alpha. And if the p-value is less than alpha, we say that the test result is significant. Always remember, if the p-value is less than 0.05, we'll say that the result is significant and we reject the null hypothesis. And if p-value is greater than 0.05, generally, it could, it depends on what your alpha level is. We always say that we fail to reject the null hypothesis. Now, there are some other implications related to this, okay? So, one of the implications which are related to this is, there are a lot of people where I've seen a lot of instances where people say that, we accept the null hypothesis. That is a wrong way to say it. You never accept the null hypothesis. Why do you say that? The court says that, this person is innocent. No, the court never says that. The court always says that based on the evidence, we don't find this person guilty. We don't hold this person guilty. Thereby, meaning that the person was always innocent. So you don't have to establish his innocence. He was always innocent. You have to establish his guilt. That is what I have been trying to say all along. That null hypothesis is something which is assumed to be true unless proven otherwise. Okay, so that leads us to something very, very interesting: the terminology. Okay, the terminology related with hypothesis testing. Okay, so let me just go ahead. Let me just scroll down. I'll come back to this. We'll come to a little bit about hypothesis testing. Okay, so there are different steps which are involved in testing the hypothesis, statistically testing the hypothesis. That is, you have to select the test based on the data type and its condition. So ultimately, you will have to look what kind of variables do you have. I told you variables are pretty important. So whether it is a categorical variable or you have numeric variables, or you have a combination of categorical and numeric, ultimately everything would depend. So you could have a t-test, you could have ANOVA, okay, you could have what you call as a chi-square test if it's a categorical variable. So ultimately you have to choose the test. Okay, then the second step is you have to state, in terms of hypothesis testing, we're talking of hypothesis testing, you have to state the null and the alternate hypothesis. So always remember that alternate hypothesis is the exact opposite of the null hypothesis. How we state it, I'll discuss that in a short while. Okay, so we'll state the null hypothesis, and this has to be stated in a mathematical format. Okay, and we have to state the alternate hypothesis. When we are talking of hypothesis testing, we have to determine the level of significance. Okay, this is what we were talking of right now. That is your alpha, whether it's going to be 0.05, whether it's going to be 0.01. That is alpha at 5% or alpha at 1%. Okay, then the next step is we compute the p-value for the test status, and then this is result. So we'll in a short while do it. Okay, I'll show you how it can be done in the case of certain, we'll take up certain examples and I'll show that to you. Okay, so in relation to hypothesis testing, we are actually, why do we are talking of probabilities and things like that? Because we are always dealing, generally in statistics, we are always dealing with a sample. We are not dealing, we don't have absolute knowledge. We are not talking of the population. So when we don't know about the population, we are always trying to predict something, and that prediction is actually based upon the sample. So unless, if it would have been a census, things would have been much more easier. But since it's not a census, it's always sampling. So, we are always making a prediction, and there could be errors in those predictions. Okay. So hypothesis testing is formulated in terms of two hypotheses. That is, you have the null hypothesis, you have the alternate hypothesis. Here, I would like to make a point. Okay, and my point is very simple here, is that in many of the recent researches, you may find that the authors generally tend to skip the null hypothesis, with the assumption that people, by merely looking at the alternate hypothesis, the testable hypothesis, alternate hypothesis is always called as the testable hypothesis. Okay, so by merely looking at the alternate hypothesis or the testable hypothesis, people will know what the null hypothesis is. So you will find that some authors, some theses, some researchers may not have the authors may not strictly follow this guideline of stating the null hypothesis and the alternate hypothesis. Okay, so many times you'll find that in some research papers, many times you'll find that the null hypothesis is not written, only the alternate hypothesis is written. So alternate hypothesis, there are two ways to write the the alternate hypothesis. One is you could use H1 or you could use HA, and then obviously the subscripts, you could number them accordingly. So H0 is written as the null hypothesis. Why do we write H0? What does it actually denote? It denotes the word null. Null means zero. Okay, that means there is no difference. There is no difference amongst the parameter. Okay, so there is no difference. in terms of the parameter that we are talking of. Okay, so that is why it is always written as, and no difference means 0. So that's why it is always called as a null hypothesis and represented as H0. Okay, so like I said, null hypothesis is the default, what is established, or true. So null hypothesis is something which is always assumed to be true, and you as a researcher try to collect evidence to in support of your hypothesis, which is actually your alternate hypothesis. So hypothesis is always termed as the researcher's hypothesis. Null hypothesis is something which is termed as the something which is universally thought of as being true or established. Okay, and like I said, alternate hypothesis involves the claim to be tested. Now in this slide you can see that it is not written as H1, but it is written as HA. So there are two ways to write it. Okay, so you can write them, you can either write hypothesis, alternate hypothesis with a subscript of 1, or you could actually choose A. Okay, 0 is always associated with H0, okay, or whatever you would want to call it. H0 is always associated with null hypothesis. Okay, now always remember, these are the possible outcomes, which I was just telling you a few minutes back. You reject the null hypothesis and you accept the alternate hypothesis because in your sample, you have sufficient evidence, in favor of the alternate hypothesis. Or you do not reject, the alternate hypothesis because of insufficient evidence to support H1. Take the example of that, the court case that we were talking of. And in the court case, what happens? Let's say the prosecution is not able to put up, what happens? Sufficient evidence. So we will not reject the null hypothesis. Why do we not reject the null hypothesis? Because the null hypothesis that the person is not guilty or the person is innocent. So we will not reject it. We will not say we accept. So we are not establishing something that, we are not establishing his innocence. We are not establishing his innocence. The prosecution, always remember that. The prosecution that is not testable. The prosecution is establishing his guilt. But they fail to, establish his guilt. That means we will not reject the null hypothesis. And what was the null hypothesis? The null hypothesis was that the person was innocent or the person was not guilty. So we will never see. This is something which, you need to make note of. A lot of people make this mistake. They say accept the null hypothesis. Never. Null hypothesis is never accepted. You either reject the null hypothesis or you fail to reject the null hypothesis. Okay? You never say that, null hypothesis is accepted. You fail to reject the null hypothesis. Always remember this. That's a distinction. A lot of people make this mistake. A lot of people, when I say a lot of people, I don't mean generally the faculty members. I mean the young scholars. I've come across many theses where people use the word null hypothesis accepted. No, never. Null hypothesis never accepted. Either it is rejected or you fail to reject it. Okay? Always remember that. Yes, alternate hypothesis, that is your H1. Alternate hypothesis, can be accepted or it is rejected, depending on, whether you are able to collect data in support of it or not. So if you collect the data in support of alternate hypothesis, it stands to get accepted and the null hypothesis gets rejected. Always remember this. That is the key distinction. Very important. I always make this point. You never ever, say that the null hypothesis is accepted. There is no formal outcome that says accept H0. Never. Okay? You only say that we fail to reject the null hypothesis because we have failed to collect, we do not have sufficient evidence in support of our hypothesis, that is our alternate hypothesis, that is H1. If we don't have sufficient evidence, that means that we have failed to reject the null hypothesis. That's it. You never say accept the null hypothesis. Always remember this. That's the distinction, okay? So, the court case that we were talking of, so our alternate hypothesis was that the defendant is guilty and our null hypothesis was that the defendant is innocent. So, if innocent is rejected, okay, that H0 is rejected, then what happens that you have support of, your alternate hypothesis, that is the defendant is guilty. Okay, so always remember this. That's the distinction that you need to make. So remember this, H0 is always the mathematical opposite of HA. Okay. So all statistical conclusions are made in reference to the null hypothesis. Okay. And alternate hypotheses are the testable hypothesis. So as researchers, we either reject the null hypothesis or fail to reject the null hypothesis. We never accept the null hypothesis. This is something that you need to remember. Okay. Now, when we are dealing with, hypothesis testing, we have this alpha, we have this, if you look at this particular, curve, it is what you call as many people would call it a uniform distribution curve or a normal distribution curve. And this is true, It has this curve, people call it left tail, right tail, as you can see. The one on the left hand side is called as the left tail. It has got two tails. Okay, this curve. One of the tails is called as the left tail, which is also the term that you might encounter in many of your, research papers or even textbooks. That is called as the lower bound. So the lower bound actually is the light blue line that you can see, and it is written as lower, and it is always termed as the lower bound. And right tail is always referred to as the upper tail, and sometimes you'll come across the word the upper bound. Okay, this is for those of you, I believe most of you are actually aware of what this curve is and what this distribution is and the properties of this distribution. Okay, and that is the values or the probability that you have in these tails. Okay, so I'm sure all you are aware of these concepts. So again, when we are talking of these tests, we are talking of how to mathematically write. You remember one of the things was we have to state the null and the alternate hypothesis in a mathematical way. So when we are talking of a two-tailed test, okay, and you can look at the picture. Two-tailed test means that your alpha lies in both the tails. Okay, so alpha if is 0.05, okay, or alpha is 5%, the 2.5% would lie in the left tail and 2.5% would lie in the right tail. Okay, and when we are saying that it is a left tail test, so the entire alpha 5% would lie in the left tail, and 5%, if it is the right tail test, the 5% would lie in the right tail. Now this appears to be very confusing, okay, for many people. What is this tail and what is left tail, right tail? As a researcher, when you start working, when you start dealing with numbers, again, like I said, that many people only write the alternate hypothesis. Similarly, in this instance, in this case also, you just test for the difference. You do a two-tailed test, and just by looking at the numbers, you can easily make out, but you can easily make out whether it's a left-tailed test or a right-tailed test. Okay, so I will just talk of let's talk of the two-tailed test first. Okay, so what is assumed to be true is written as equal to, and the alternate hypothesis is written as not equal to. Okay, I'll give you another example. Let's say you have a 1 liter Pepsi bottle, okay, or a 2 liter Pepsi bottle. So you are a manufacturer, you are manufacturing and you are selling Pepsi, and your bottle contains 2 liters. There is a consumer, or there are a group of consumers who feel that no, there's something wrong actually, and Pepsi is kind of saying it's 2 liter, but it is not 2 liter. Okay, so he says that I personally feel that the volume, the amount of Pepsi, in that 2 liter bottle as claimed by the manufacturer is actually not 2 liters. So what is the null hypothesis? The null hypothesis is what is assumed to be true, that is H naught is equal to 2 liters. And from the consumer's perspective, the consumer is saying that the bottle is, I think the volume is not 2 liters. Now when he says the volume is not 2 liters, it means it could be more than 2 liters, it could be less than 2 liters. So there are 3 possible scenarios here. The 3 possible scenarios are either it is equal to 2 liters, it is more than 2 liters, or it is less than 2 liters. Okay, So when we are saying that we want to find out, our claim is that the bottle does not contain 2 liter. That means we are not concerned whether it is more or whether it is less. What we are trying to just say is that there is a difference, merely a difference, and it is not 2 liters. So in that instant, we will use a two-tail test. When we are not concerned with the direction, left hand or right hand, more or less, when we are not concerned with that, we use a two-tail test. Okay, when we are talking of the difference. So we'll say that H naught is written as equal to, that is H naught equal to 2 liters and HA not equal to 2 liters. And this could be, and by looking at the data, we can make out whether it is in the right, whether it is in the right hand side or left, tail, right tail. But we'll say that. So when we are talking of two tail, we are only talking of the difference. We are not concerned with the difference if it is more or if it is less. Okay. But let's assume there is somebody, who says that there's a consumer who says that no, my contention is that the cola bottle is less than 2 liters. So we will use this particular sign to denote the alternate hypothesis. Less than. The consumers, what is the assumption? What is the assumption here? What holds true? That Pepsi has 2 liters. Okay. But from the consumer's perspective or the customer's perspective, he says his hypothesis is that it is not 2 liters, it is less than 2 liters. So we'll use the sign less than. And what will be the alternate hypothesis now? The alternate hypothesis will be greater than or equal to 2 liters. So as long as it is 2 liters or more, as long as it is 2 liters or more, the manufacturer is right. And we will not reject the null hypothesis. That is, we will say that yes, the manufacturer is right. It is 2 liters or it is more than 2 liters, but it is not less than 2 liters. Now, think of a perspective of the manufacturer. If you look at it from the perspective of the manufacturer, now the manufacturer feels no, there's something wrong. There's something wrong at the bottling plant. He says that my hypothesis, my assumption is that I want to prove this, that the bottling plant is making a mistake. And the bottling plant, the volume is not 2 liters. So as long as it is 2 liters or less, the manufacturer is not bothered because he's not making a loss. But as soon as it is more than 2 liters, he starts making a loss. So he will frame, a right-tailed hypothesis. And in this case, the null hypothesis will be written as less than equal to. That means, this is assumed to be true, that it is, less than equal to, and his hypothesis is that it is more than 2 liters. Okay. So this is the concept of the tails of the test. Okay. And this is, in a nutshell, this region is the 95% or the 99%, depending on what you have chosen as the alpha. Okay. So 1 minus alpha is the rejection region, okay, or the confidence level, and we are confident that our values lie here. Okay, so this is the rejection region. So if your alpha calculated probability, the p value, is somewhere here, you are going to reject the null hypothesis. Okay, so that is what we say, that we got a value of 0.05. Okay, and our value is lesser than 0.05, we say that the test is significant. We always say that, remember, if P is less than 0.05, P is your calculated, P is always calculated, and alpha is never calculated, it is a standard. So alpha is 5%. Okay, so when you say alpha is 5%, it means 0.05. Or 2.5, alpha by 2.5 in this tail and 2.5 in this tail. And when we say that, alpha is, the P is less than 0.05, we say that, the result is significant. We always use the word significant. And when P is greater than 0.05, we always say that the result is not significant. And when the result is not significant, we fail to reject the null hypothesis. That is, we do not reject the null hypothesis. And when the p value is less than 0.05, that means the alpha lies either here or here, and we are going to reject the null hypothesis. Okay, so this is how you look at the graphs. Okay, so in an hour, I have an hour to discuss all. I had an hour to discuss all these things. Now, obviously, the concept of the uniform distribution would require at least another hour to explain. But I'm sure there's something which all of you are aware of. Okay, so what are the things? If you look at this, let's take some examples. Okay, so how do we choose a one-tailed test, and how do we say that it's a two-tailed test? Okay, so and these are also called as directional. If it is a tail test, we call it directional because it is in one direction, in left tail or the right tail. And when it is a two-tailed, it is non-directional. Okay, look at the first. Are engineers less extroverted compared to statisticians? If you look at the first one, you can clearly make out that we are talking of a direction. We are saying, are engineers less? That means we are talking of one being greater than the other. So it has a direction. But if you look at the second one, is there a difference in memory retention? So we are only talking of the difference. We are not talking of what the difference is, who is more or who is less. So this is basically a two-tailed test. Similarly, if you look at the third one, again, it says, is there a difference in college GPAs for students who are homeschooled than for students who went to public school? So what are we trying to find out? That is there any difference between students who did not go to school or who went to public school? So the only thing we're interested in finding out the difference. We are not interested in finding out who has a better score or who has a lower score or something. If that would have been the case, then it would have become, a directional test. And depending on who we want to keep where, more or less, if we use the word less, it is a one-tailed test. If you use the word more, it is again a one-tailed test. And when we use the word difference, it means we are only interested in finding out whether there is a difference between the males or females, okay, or homeschooled or public school. Look at the fourth one. Do people who take vitamins daily live longer than people who don't? Now here the question is live longer, more. Okay, so when we have more, it means it's a directional test. We are talking of one being able to live more than the other. So it's a directional test. Okay, fifth, are extroverts less stressed than introverts? Again, the question, less stressed. So when we are talking of less, we are comparing between two groups, okay, and we are saying that one is more than the other or one is less than the other. So it becomes a directional test. Okay, does the yearly income for nurses differ from the yearly income of air traffic controllers? Here we are not interested in knowing who is earning more, who is earning less. We are only interested in finding out the difference. So when there is a test of a difference, it becomes very, very simple. It becomes a non-directional two-tailed. Now, as researchers, I'll tell you, as you start doing these things, you will never think of things in one direction or two direction. You will always do a two-tailed test, and from that you will actually conclude, the direction itself and how it's going to look like. Okay, so that comes with practice. But just for your understanding, this is how it is. Okay, so let me just go back. If we just go back, to what some of the examples that we've seen. Look at this model. Okay, look at this particular model. Now, in this case, I have these what we call as hypotheses. Okay, and these are all directional hypotheses. If you can look at these, because they are represented as plus and minus. If you can see, this is represented as a plus and this is represented as a minus. So I have, my model, my research model says that exam stress has a positive impact on physical or mental anxiety, and I have written this as a plus. So it means it's a directional hypothesis, and it is written as a plus. If you look at this one, physical mental anxiety, okay, lessens your performance, or it has a negative impact. Okay, so that means it's a directional, but it actually lessens the impact of the score, exam score. Okay, similarly, exam stress, there's a positive impact of exam stress in terms of exam preparation. Now, this is something, many of you may question this, saying that how is this possible? I mean, if you are stressed out, your preparation it will not have a positive impact. But then you could have literature in your support. In the case of this gentleman who had made this particular research or hypothesized model, in his case, there is a realization that exam stress, the more stressed out that you are likely to prepare more. That's what his literature says. There are people who would say the opposite. The people who would say that the more stressed you are, the less likely you are to prepare. And exam preparation, obviously, we all know that there is no dispute about this, that the exam preparation, will have a positive impact on exam performance. So this is how you make your hypothesis. These are all directional hypotheses, okay? So if we just go back, these are all examples of directional hypothesis. This model, if you look at this model is an example of a directional hypothesis, that job satisfaction has a positive impact, or it may have a negative impact on work commitment. But what does theory tells us? Theory tells us that job satisfaction is likely to have a positive impact on work commitment. So this is a directional hypothesis. So most of the time, people tend to write, if you look at this particular model, entrepreneurial orientation has look at the first hypothesis. What is the hypothesis? It is written as H1. It is never written as H0. Why do we write it as H1? Always remember this, in your conceptual model, you will never include H0. This is your analytical model. Remember what we said. Alternate hypotheses are the testable hypothesis. You are testing that. So your research model is basically your testable model. H0 is never testable. It is only the alternate hypothesis which is testable. So that is why always remember, in your research model, conceptual model, hypothesized model, you will only write the H1 or your alternate hypothesis, H1, H2, H3, whatever there might be. So in this case, if you look at this, entrepreneurial orientation has a positive impact on marketing orientation. Marketing orientation has a positive impact on organizational innovation. This is what I am saying. I could always say that marketing orientation could have a negative impact. So my hypothesis would become that marketing orientation has a negative impact. Okay, this could be my hypothesis. But again, whether it is negative or positive, whichever way I say it, it's a directional hypothesis. It is a one-tailed test. Okay, so when I say it has a negative impact, it becomes a left-tailed test. When I say it has a positive impact, it becomes the right-tailed test. Okay, organizational innovation has a impact on. When I say organizational impact has on business performance, what does it mean? It means there is an impact. We are not interested in finding out whether the impact is positive or negative. But when we write organizational innovation has a positive impact on business performance, it becomes a right-tailed test. When we say organizational innovation has a negative impact on business performance, it becomes a left-tailed test. So this becomes a directional test. So it all depends on how you write the hypothesis. Look at these. These are all hypotheses which are written as directional, except for H7 and H8. Entrepreneurial orientation has positive and significant effect on marketing orientation. This is a right-tail directional hypothesis. H2 again directional hypothesis. H3 directional, H4 directional, H5 directional, H6 directional. Okay. Now the point here is that majority of the researchers, or I said quite a large number of researchers you will come across, they don't write the null hypothesis. They don't want to waste, especially when you are writing the research papers, they don't want to waste space by writing the alternate hypothesis. Sorry, by writing the null hypothesis. They only write the alternate hypothesis because they feel that when anybody reads the research paper, he can actually, find out, because there is, the null and, the alternate, they are the mathematical opposite of each other, right? So then, like I said at the beginning, the null hypothesis and the alternate hypothesis are, the mathematical opposite of each other. And alternate hypothesis is the theory, is something that you are trying to prove. So here in our research model, we are trying to prove, if you look at the first hypothesis, that entrepreneurial orientation has positive and significant effect on marketing. That's what we are trying to prove. And we'll try to collect the data. Now the data could be such that our hypothesis would be rejected. There is a possibility. There could be a situation where, the data says that entrepreneurial orientation actually has a negative effect on marketing orientation, right? So that's also a possibility. So ultimately, always remember that alternate hypotheses are the testable hypothesis, and they're always the exact opposite of the mathematical hypothesis. They're the mathematical opposite of the null hypothesis. So I think I have exceeded the time limit. 1 hour is, I personally feel is very, very, less to, actually go into the depths of all these things. But let me just very briefly summarize what we have discussed. Okay, let me just recap whatever we have discussed. One is, especially for the young researchers. I'm sure the faculty members are very well experienced and they have their own ideas, and they must have, studied so many different researchers, and everybody has their own unique style. But for the young researchers, let me put it this way, that, you generally tend to start, any good research tends to start with a question in your mind, usually a question. It might not be, or there could be a lot of questions, but you usually tend to start with questions, with a dilemma. Does this happen? What leads to this? So you always tend to think in terms of some sort of question. A good research needs to have those questions, which has to be followed up by objectives. And you need to have a strong conceptual and a theoretical framework, okay, based on the theories and the concepts, okay, that you have studied. The link between research hypothesis and objectives and your research questions and research objectives and hypothesis is that it is basically, the research questions and the objectives help you formulate your, research hypothesis. Research hypothesis formulation, as I've told you, it's always, especially in the case of quantitative studies, it is always in the form of, a null hypothesis and an alternate hypothesis. A null hypothesis is something which is always assumed to be true. It is the status quo. And alternate hypothesis is something which the researcher is trying to establish. And what does the researcher do? He collects data in support of that. Obviously, when you are saying something happens, like for example, this gentleman says, if you look at this first, he says that entrepreneurial orientation has a positive and significant effect on marketing orientation. So he believes this. And he's trying to collect data on this. Now, ultimately, everything depends on the data. Whether his hypothesis is accepted, his alternate hypothesis is accepted, or his alternate hypothesis stands to be rejected. Okay? And if you compare this with the court case, the prosecution tries to prove that the person is guilty, which is the alternate hypothesis. And if he cannot produce sufficient evidence, the judge will say that, no, your alternate hypothesis stands to be rejected, and we fail to reject the null hypothesis, and the person obviously continues to be innocent. It is not that you establish his innocence. So null hypothesis is never established. That is why we always say that the alternate hypothesis is a testable hypothesis, and in your research model you will always have the alternate hypothesis. Okay, so that's one thing that we have seen, we have discussed. And then we have discussed the significance of the tails. Okay, so you have the directional hypothesis, and the direction could either be, in positive direction or in a negative direction. It could be more, written as more, or it could be written as less. So when we say less, or negative, it is the left tail test. When we say more or positive, we always talk of the right tail test. When we are not talking of, which is more or which is less, but we are only saying that, yes, it has no impact or there is no difference, we are always talking of, a two-tailed test. As you go along, especially with the young researchers, when you do a lot of research, you'll come to the conclusion that you only need to, actually run a you don't need to run a directional hypothesis, but you can, by just merely looking at the results, you can conclude the direction on your own. Okay. So this is very, very, really about your research objectives and hypothesis testing. Okay, in hypothesis testing, there are certain steps. The first step is obviously, you need to look at, the kind of data that you have, okay, and the kind of variables that you have. So that's very, very important when it comes to hypothesis testing. The kind of variables. The variables could be, categorical variables, like for example, you have gender, and your other variable could be, the other variables in your study could be, numeric. So if there are two categorical variables, you could actually go in for a chi-square test. If there is a categorical variable, or a numeric variable, then you can have many other, you can have t-tests or things like that. So ultimately, you have to decide, on the kind of test, and the kind of test that you are going to employ would be based on, the kind of variables that you have. Okay, so that's one dimension, and then ultimately you have to decide, what is going to be your, alpha. Okay, so you have to choose the alpha. The general trend is to choose an alpha of 5%, which is 0.05, or sometimes when you want to be very, very strict, you want to choose an alpha of 1%, which is 0.01. Okay, then what do? You calculate the p-value, the test statistics. Okay, you calculate the p-value and you compare it with your alpha. You make a comparison, and when you make a comparison, if you find that the calculated p-value is less than the alpha, what do? You say that the result is significant, you reject the null hypothesis. And the calculated p-value is more than the alpha, whether it is 0.01, it depends on what you have chosen the alpha. If your p-value is more than your alpha, calculated p-value is more than the alpha, you fail to reject the null hypothesis. Okay, you say that the result is not significant. So this is in very brief and in a nutshell. I've tried to accommodate everything in an hour. And what I'll do is I'll share the PowerPoint presentation with the organizers. It has much more details. If you can just when you can read it at your leisure. It has much more details. So I'll just scroll down and you can see I have put in a lot of details here related to all these things. So the p-value approach and other things which can actually make a little bit, which will make good reading and will provide you with some ready references. So I thank you all for listening very, very patiently to me. And with this, I'll stop the presentation. I hope.
Thank you very much, sir, for your simplified explanation about formulation of objectives and hypothesis. We have some queries, and I would be putting up before you one by one. So the first question is, what is research hypothesis and how do we write the hypothesis?
Okay, so I think, I tried to explain this in the lecture also. Your research hypothesis, like I said, when you are writing the hypothesis, you have to write it especially when you are trying to test it, okay? And so you have to write it in the null and the alternate form, okay? And null is, like I said, it is the status quo. Or I took up some examples. I'll just illustrate with the help of the example. I am saying that one example is, like I'll take the previous example that, female students are better than male students. So this is my alternate hypothesis, okay? Now, what is my null hypothesis? Is going to be the exact opposite of the alternate hypothesis. So I'll say that there is no difference between the male and female students. Okay, so this will become my null hypothesis. And the alternate hypothesis is that there is a difference between male and female students. This is a non-directional hypothesis. But my hypothesis is that females are better than male students. So this becomes a one-tailed hypothesis. It becomes a directional hypothesis if I write it that female students are better than male students. Okay, so this becomes a directional hypothesis. If I write that there is no difference, if there is a difference between male and female students, it becomes a non-directional hypothesis, alternate hypothesis. The null hypothesis would be that there is no difference between male and female students. Okay, so that's how you write the null hypothesis. Null hypothesis is not testable, alternate hypothesis is testable. So different researchers will have different research hypotheses. Okay, so your research, the wording will be different. It will depend what are the key variables. So the research, like I said, if you go back, if you have a look at the slide, I told you, research hypothesis also involves your variables. Okay, so we were talking of, I gave you some examples of, for example, exam score, exam performance, exam stress, or antiplan notation, business performance. So these were the variables. So you have to take the variables into account, and you have to, you are trying to predict a relationship between those variables. Like I said, my prediction is that exam stress will have an impact on exam performance. Okay, so these are the two variables, right? So my null hypothesis will be that there is no impact of exam stress on exam score. And my alternate hypothesis would be that there is a positive impact of, or there could be a negative impact of, exam stress on exam score. Okay, so that's how you write it.
There's one more question related to this only. that how do we decide that how many hypotheses should be framed? But
Oh, that's a very good question.
Yes.
That's a very good question because it does not involve statistics. It's actually subjective. Okay. So ultimately, in any good research, I mean, it all depends whether you are writing a research paper, whether you are writing a PhD thesis. I have seen scholars, having the main hypothesis, and then you have the sub hypothesis in those. Ultimately, it all depends, on your research questions or your objectives, what you are trying to establish. So if you are trying to establish 3 things, you are trying to establish 4 things, you will have to have those many, hypotheses. Okay. So you have to make sure that whatever you are, that's why, I see many presentations, and in many presentations, I always find that there's a question where, some of the people who are listening to that particular research synopsis presentation, they'll always say that, oh, you have so many objectives. Now, when in a research, it is not possible to have so many objectives. Please cut down on your objectives, make it manageable. That's the basic idea. If you have lot many objectives, you are likely to have lot many, research hypotheses. Okay. So ultimately, it all depends on what is a manageable number, and that manageable number, there is no formula. It is only subjective in nature. Okay. As a researcher, you as a researcher, your guide, they have to guide you in terms of the number of hypotheses that you need to keep. But ultimately, the number of hypotheses will depend on the objectives that you have. The more objectives you have, the more research questions you have, the more hypotheses you are going to have. And in any research, you have to keep them at a manageable number. Okay. So there is no formula which says that you need to have 10, you need to have 20, you need to have 5, you need to have 4. There's no formula. Everything is subjective here.
Again, I think that depends upon the nature of objective also. What type of objective has been framed, whether we are taking primary data for it or we are taking secondary data, even that would be considered for framing the hypothesis.
Yes, ultimately, what you are trying to achieve at the end of the day, what you are trying to predict, if you are trying to predict 5 things, you will have 5 hypotheses. If you are trying to predict 6 things, you will have 6 hypotheses. And this prediction has to be related with your objectives, has to be related with your, research questions. So if you have many research questions, you will be trying to predict so many things. So, for example, if we take the example of Copernicus has had only one hypothesis, that it is the sun which revolves around it is the earth which revolves around the sun. So that was his hypothesis. So in his study, there was only one hypothesis. Okay.
Actually, these days, scholars, they get confused that if they are having a lot of hypotheses, their research work is good. So that is why I think this question came up.
Can I make a point not completely related with this discussion? Let me tell you, I personally do a lot of researches which are actually, cause and effect kind of relationship. Let me put it, impact of one variable on another. Okay. And that is a formula kind of thing. That is, I apply SEM all the time. And so my modeling is always like that. Now, I always tell my scholars these days, over the period of time, I have come to realize that people have stopped using, t-test or simple tests. People are now only concerned with, some very grandiose kind of modeling techniques so that they can impress the examiner. But what they forget is that ultimately your data, your variables, your conceptual framework guides you to the kind of test that you are going to apply. So in certain instances, t-test is the right test. In certain cases, ANOVA is the right test. Okay, look at COVID. So we have a lot of experimental research, in terms of the efficacy of drugs and all these things. So people are only using t-test, or people are only using, ANOVA and contrast. Nobody is using structure equation modeling there. But what has happened over a period of time, and I've seen this in my department also, that even the faculty members, they are saying, "Arey, isme SEM nahi lagaya, tumhari research to sahi nahi hai," without realizing that SEM is not required. So, like you were saying, you are absolutely right. A lot of scholars think that unless and until there are 20 hypotheses, my research will not consider to be, a good research. If I only use t-test, if I only use chi-square, my research will be considered to be an inferior research as compared to somebody else's research. So, never ever, this is my suggestion to all the young scholars. Never ever worry about these things. Your methodology, has to be driven by, your research strategy, your research design, not the other way around. Don't reverse engineer. Don't decide on a methodology that I'm going to use, or a tool or a technique that I'm going to use, SEM, and then, work around and, formulate your hypothesis. Your hypothesis, your data, your variables, they should actually guide you as to the kind of research tools and technique that you're going to employ.
We were talking about Z-test and T-test. So, sir, we have two questions which are related to these tests. That what is Z-test actually telling us? When are we supposed to use the Z-test?
Okay. You see, that's a very interesting question, although I never discussed that, but I would like to answer that. You see, Z-test and T-test are actually kind of synonymous, okay? If you look at the softwares that you have, the softwares, they automatically, it has to do with the sample size, by the way. So if the sample is, if you look at, it has to do with the distribution. You need to understand the Z distribution and the T distribution, okay? So in the T distribution, the T distribution has to do with something called as degrees of freedom, okay? That is the sample size. It is related to the sample size. So that the sample size is 5, the degrees of freedom is 4. If the sample size is 6, the degrees of freedom is 5. So what happens, if you look at the T distribution is much flatter, okay? And more data, more probability is contained in the tails. So lesser the sample, more is the probability in the tails, okay? That is the tails contain more information, okay? If you will give me a minute, I can actually just, show you something. If you give me a minute.
Right. Sure.
Yeah. Okay. So I can just present something to you here, and luckily I had this slide with me. So I'll just share the screen and look at this. So I have these distributions, okay? So look at these. This is an example of a T distribution. Now the T distribution, if you look, this is case 1, case 2, case 5, case 10, case infinity. What we are trying to say is that as the sample size increases, okay, this curve that you can see, okay, as the sample size increases, the curve actually becomes, more peaked, and the values actually lie here. But if you look at, with less number of sample, the more the values are lying here also. So this is the difference between, here there's the degree of freedom is 1, where you have only the sample size is 2, degree of freedom is 3 when the sample size is 4, and degree of freedom is 20 when the sample size is 21. So you can see, if you look at the tail of this red one, where the sample size is 20, when the sample size is 20, you will find that the values in the tails are lesser. But if you look at, this one, the blue one, the tail is much more broad here. So a lot of information is here. So the probability lying in the probability, you see, this is all about the probability, 0 to 1. The area under the curve is always 1. Always remember this. That is, probability for anything can be from 0 to 1. So this is what the curve is. So this curve contains all probabilities. The total of all these probabilities is 1. That is why we talk of 95%, alpha 0.05. So in this case, what happens in the case of smaller samples, if in the case of smaller samples, the probability lies more in the tails as compared to samples with a greater. But if you look at the T distribution, and the difference between T distribution and Z distribution disappears as the sample size starts increasing. So after it is said, there is a convention. Okay, it is not the rule, by the way. There is a convention which says that as you move ahead, when the sample size becomes 30, 35, 40, 100, 200, the T distribution actually becomes the Z distribution. So there is no difference, okay, between a T and Z when the sample size is large. And when the sample size is small, then the T distribution is different from a Z distribution. Okay, so that is in a nutshell what is a T distribution and what is a Z distribution. Okay, and when to use when. So if the sample size is large, we always use a Z distribution. When a sample size is small, when we're talking of 5, 6, 7, 10, 15 people, we are talking of a T distribution. Okay, and the statistical difference is that the values in the tails, or the probability that lies in the tail, is much more when we are talking of small sample sizes. And that is the reason why smaller the sample, less is your predictive power. Bigger the sample, more is your predictive power, right? Because if we sample everybody, we have a census, we are absolutely certain. So as you increase the sample size, the certainty increases. And that is where the probability is very closer to the mean. Okay, so you will be much more closer to the mean. In a t-test, it is much more flatter and more information is contained in the tail, more probability is in the tail. The lower the sample size, more the uncertainty. Okay, but the distinction between a t and a z is that they are basically distributions, but when the sample size becomes large, more than 30, it is said. It could be 27 also, it could be 28 also. The convention is to say that when the sample size is more than 30, T and Z distribution, they become one and the same thing. Okay. So you can use software automatically. The software is very clever. When you are using SPSS or when you are using, Excel, it actually looks at the sample size and computes accordingly. Okay.
There are two more questions, sir. There's one question. What about writing the hypothesis statement? Are girls better than boys and vice versa? The question is that can we add the term vice versa in the hypothesis statement itself?
No, if it is a directional hypothesis, you have to, if your hypothesis, alternate hypothesis is directional, you have to either say boys are better than girls or girls are better than boys. Okay, so you have to list it that ways. It will mean the same thing. Like, let me just tell you like this. If you write a hypothesis that female are better than males, okay, this is a directional hypothesis. It could other way around. You could write it in the negative way, that boys are lesser than, girls. So you could write it that way. So you have to write it in one way. And if you are saying you are only talking of the difference, so you would write that there is a difference between the exam score of male students and female students. Here you are not talking of the direction. Okay. So ultimately it all depends on your objective. It all depends on your question. If your question is that females are better than males, then you will write a directional hypothesis that female students are better than male students. If your research question is that there is a difference between एक difference है, male और female students में difference है, बस आप ये नहीं कह रहे कौन ज़्यादा है कौन कम है, then you will write a non-directional hypothesis. You will only write your alternate hypothesis is that there is a significant difference between male and female students. What is that difference? You are not bothered. Okay, so ultimately everything boils down to your research question. Your research question is that there is no difference. There is a difference between male and female students. Your hypothesis will become a non-directional hypothesis. If you say male students are better than female students, your alternate hypothesis is this. If your research question says that are female students better than male students, then that is your research hypothesis. Okay, so it could be, when it is directional, it could be less or more, and when it is the difference then it is a non-directional hypothesis. Okay.
What I understood is that in both the cases we cannot write vice versa. We have to be directional only. That what are we trying to find out?
Yes, we have to be directional because we are testing something, so we can test only in one direction.
Okay? We cannot write both the things.
We cannot write both the things, right?
Either this or that. Okay.
Either this or
that. Then we come to the last question. It's a bit tricky question, but hope you get it what they are trying to ask. What is the relationship between null hypothesis and thesis statement? I think these are thesis statement, maybe the title of the thesis.
Okay, very good. It's a good question. Okay, the question is if it is thesis statement is assumed to be the title of the thesis. You see, there is a flow, there is a linkage. You have the title. Okay, title is at a very, very broad level. Okay, title is something which only gives you an idea about the study. It does not define the scope. Okay, or anything. Sometimes you have those kind of titles also, but generally speaking, what happens? Your objectives actually flow from the title. That is the flow. So your objectives are drawn from the research title, and that is how it should be. Always remember that. Okay, so as young scholars, as young researchers, your objectives have to flow from the title, and that is the observation of many of the evaluators. Many times we find that there are research theses and the examiner makes a comment and he says that the objectives do not flow or there is no linkage between the objectives and the research title. So the research title is at a higher level. So research title, and then you have the research objectives. Okay, the linkage, and I think the thesis statement, somebody probably means the purpose or the ultimate objective of what you are trying to do, or it could be in the form of a research question. Ultimately, thesis statement, these things are all subjective. Different people use different words. For example, people use the word theoretical framework and they actually mean the conceptual framework. Many people call it as conceptual framework and they actually mean theoretical framework. Many people don't know the difference between these two. And to be really honest, when we are working, when it comes to the actual, practice, nobody makes any distinction between a theoretical framework and a conceptual framework. So thesis statement, in some instances, could be a word which actually means a specific thing. But like Asma ma'am said, if we think of it as a title, then obviously your objectives have to flow from the title. Okay, and that's the relationship. Yes, ma'am. Any other
So
question?
we come to the end of the question answer session. We had a lot of interesting questions, and even I came to learn a lot of new things from your lecture. So we come to the close of the today's session, and I have the pious duty to extend the propose of the vote of thanks also. So first of all, I especially thank you, sir, for giving us time and picking up a very pertinent topic of framing objectives and hypothesis formulation, because it is always a very tricky job. It is a very complicated job to frame a right hypothesis. And all of us are budding learners and researchers, and I hope our scholars have also learned a lot from this lecture today. And now they would be more clear about how to frame objectives and how to formulate the hypothesis. And I also extend my heartfelt thanks to the higher management of the campus for allowing us to conduct this 14 days of quality improvement program. I also heartfully thank to the Dean of the department, Professor A.K. Saxena sir, the head of the department, Dr. Shahid Mazhar sir, for the entire organizing team of Department of Commerce and Management. Thank you once again, Bilal sir. Thank you very much for clearing all our doubts in a very simple way, because RM is full of lot of doubts, and I think we will be continuing the doubts in the next 10 years also. We keep on learning and exploring. Thank you very, very much. So we'll meet tomorrow again at 11 a.m. for the next session. And till then, stay safe and stay healthy. Thank you very much.
Thank you. Thank you.
Thank you, sir.
Thank you for giving me this opportunity.